Now, on that last video, we tried that third example algebraically, and we ended up with a quadratic we had to use Desmos to help us with. I'm going to show you what would happen if we just went to graphing straight on. Just type in the 1 over x and a minus 3. And remember, if you forget and type in the equals exactly and put the 4x over x plus 2, it's not going to give you anything. It's going to give you that little exclamation point, and that's just a way of reminding you, hey, I need everything on one side, so I would need to subtract that last fraction, and then I get this red graph there. I do want you to notice that this red graph has the same x-intercepts that the quadratic we got solving algebraically and getting that we ended up getting by solving algebraically and then having a quadratic that we graphed to get the solutions. So the solutions are the same thing, and the graph would just look like this. Now, these rational graphs, especially if you have multiple fractions in them, can look very weird. So don't worry so much about how the graph looks. Just check and find the x-intercepts, the zeros. So that would have confirmed you had -1 and 2.86. We're going to go ahead and try the last one by graphing first, and then if we have time, we might look at how to do it algebraically. Okay, so the last one, I have a 3 over x minus 1 plus 1 over x plus 1. Okay, and then on the other side, I have a 10 over x squared minus 1. So what I would do is a minus 10 over x squared minus 1. And the reason I did the minus was I had to move that fraction over to the other side. Now notice in this case, I have a solution of 2. And this is a good example of a need to zoom out and make sure that neither one of these are actually crossing. It does appear that on this side, it might actually cross over, but I'm not sure that it does. I'm not seeing a gray dot yet. The nice thing about Desmos is it will give you a gray dot. I see no gray dots indicating it crossed back over, so there must be an asymptote, must be getting really close to 0, but not crossing. So it looks like my only solution, my only x-intercept, was this gray dot at 2. This point here is actually a maximum. For the context of this problem, it doesn't matter. Only focus on your x-intercepts, your zeros. So you have a value of x equals 2. Let's see what would have happened if we would have tried it algebraically. If I would have tried it algebraically, I would have needed a common denominator. So remember, I would have to put an x plus 1 top and bottom on this fraction, since that was an x plus 1. And then I would have to put a x minus 1 top and bottom on this fraction, since this is an x minus 1. So that means I would have ended up with a 3x plus 3 for my first numerator and a 1x minus 1 for my second numerator, and it all would have been over the common denominator of x plus 1, x minus 1. And that still would have been equal to 10 over x squared minus 1. Now at this point, I could simplify this up here and cross multiply, but if you're paying careful attention, this thing here is actually the same as x squared minus 1. So if you're paying careful attention, you notice, hey, these are the same. So like we did earlier, if the fractions are equal and the denominators are equal, there's no need to cross multiply. I could if I wanted to, but I don't have to. I can just say the numerators are equal. So when I simplify those numerators, I have a 4x plus 2 equals 10. That means 4x would be 8. And dividing by 2, dividing by 4 would give me an answer of 2. So that's how you can solve this algebraically. But once again, I definitely see the advantages on one of these tougher ones to using Desmos, and feel free to use that as a way to check or even to solve these initially, as long as you zoom out to look for additional zeros that might be off your original screen.